I'll begin this afternoon's session with a brief introduction. Welcome to the Canadian Institute of Forestry's National Electronic Lecture Program. My name is Sharon Young, and I will be hosting today's session. Today is Wednesday, March 6, 2024, and this is the fifth session in the e-lecture series entitled Sharing Knowledge on Some Key Initiatives Happening Across the Canadian Forest Service. The series is brought to you by the Canadian Forest Service and Canadian Wood Fiber Centre. The CIF-IFC is very pleased to collaborate and host these webinars. For today's session, we are very pleased to have Alan Whitman and Piyush Jain, who will give an exciting presentation titled Drivers and Impacts of the Record-Breaking 2023 Fire Season. To kick things off, Alan Whitman holds a PhD degree in forest biology and management from the University of Alberta, where her work focused on fire ecology with an emphasis on remote sensing of ecological fire effects and understanding post-fire recovery in the northwestern boreal forest. Currently, she is a forest fire research scientist with the Canadian Forest Service at the Northern Forestry Centre in Edmonton, Alberta. Her recent research scope includes conducting dendrochronology analysis of historical wildfires, studying climate change impacts on fire regimes and forests, and has especially focused studying wildfires north of 60-degree latitude and in collaboration with land managers and Indigenous peoples. Piyush Jain is a research scientist with the Canadian Forest Service based out of Edmonton, where he has been part of the fire research group since 2018. His main areas of research include identifying the meteorological drivers of wildfire ignition and spread, developing improved models for fire weather forecasting, and examining the implications of changing climate on historical and future wildfire regimes. With that, I will now pass it over to Alan.
Yeah, thanks so much. We're really happy to be here. Piyush is going to be sharing slides with you all. And so, yeah, hopefully you can all follow along.
Is that all good? You can see that?
Yes, that looks great to me. And we're getting a thumbs up from Sharon. All right, so thanks so much for that introduction. Today, Piyush and I will be taking you through an overview of the 2023 fire season. I don't actually think it's a big overstatement to say that most or all Canadians were affected by that really impactful year between the widespread smoke, evacuations, people hosting evacuees in their homes, and sadly, multiple casualties and losses of life as a result of this fire season. It was a really personally affecting experience for Canadians. We'll be dealing with the emotional and health impacts of this season for years to come, just as the ecological impacts of such a large area burned in our forests are going to continue to play out over hundreds of years. So with that bit of a preamble, I just want to recognize that we're mostly going to focus on the numbers, the statistics, the weather, but there's lots that we'll be learning from this year for a long time. Next slide, please, Piyush. Thanks. This work that we're going to be sharing with you today has been a collaboration between a large group of people. If there's a specific topic or category of fire information that you're really interested in and you want to learn more, you can visit the preprint of an article that we've prepared that has a lot more detail than we'll have time to address today. This has been a project that's a collaboration between lots of different folks from the Canadian Forest Service all across Canada who are listed there on the left, as well as other collaborators from the University of Alberta, Thompson Rivers University, and Environment and Climate Change Canada. So let's talk about what happened. So much happened this year. We won't be able to highlight every single event and every story, but we'll begin with a bit of a timeline. The 2023 fire season started early, with the first main occurrence of fires beginning in April in Alberta. And it's worth acknowledging that Alberta is really known for their spring fire season, but this is more so something we associate with May, for example. So that started really early, and it turned out to be an indicator of the year ahead. Shortly after that, on May 11th, the Canadian Interagency Forest Fire Centre, or CIF-IFC as we might refer to it sometimes, set the national preparedness level to level 5, which means that the fire danger and load are extreme and agency resources are essentially fully committed. The next day, the Donny Creek fire was discovered in British Columbia, and I believe this fire grew to be the largest that was recorded in BC history. And later in May, we saw fire activity really take up on the East Coast, with the Barrington Lake fire starting and growing to over 23,000 hectares in Nova Scotia before containment, followed the next day by the evacuation of over 16,000 people from Halifax. As we moved into June, there were multiple fire starts in Quebec due to a series of lightning storms, and this led to many, many different fires burning on the landscape kind of concurrently, which is a serious challenge for fire management to respond to that level of load. And shortly after that, on June 8th, New York City experienced the worst air quality in the world as smoke was transported down to there from Eastern Canada. The next day, there was an evacuation of over 8,000 people in Edson, Alberta, and even more evacuated from the larger Yellowhead County region. And overall, in June, we experienced over 1,400 air quality alerts. In June 22nd, over 420,000 hectares burned in a single day, most of that in Quebec. And as we moved into July, which is kind of like the midpoint maybe of a typical fire season, we started to see increased fire activity in BC and a continuation of ongoing fire activity in Alberta, the Northwest Territories, and Quebec. On August 13th, tragically, the hamlet of Enterprise was destroyed by fire in the Northwest Territories, and the next day, the Canadian forces were deployed to the Northwest Territories to assist. Immediately after that, on August 15th, the Northwest Territories declared a state of emergency, and this was followed by the evacuation of the entire city of Yellowknife, so over 21,000 people on August 16th. The next day, on August 17th, back in more southerly parts of Canada, 19,809 people were evacuated from West Kelowna in British Columbia, followed immediately by the evacuation of over 9,000 people in Kelowna when fire jumped the massive barrier of Lake Okanagan, indicating really extreme fire spread and behavior. The next day, British Columbia joined the Northwest Territories in declaring a provincial state of emergency. And as we moved into September, which is when we're really typically expecting a downturn in the fire season, both BC and the Northwest Territories renewed those states of emergency, which is pretty exceptional for that late in the year for multiple regions to be in that level of situation with fire that we're still in a state of emergency. Towards the end of the fire season, on September 22nd, nearly 450,000 hectares burned in a single day in Western Canada. And finally, as we reached October, a point where typically the fire season would really be over, overall, many fires were still continuing to burn in Western Canada, but conditions began to stabilize and we sort of slowly shifted into winter and provided some relief from that really extensive year. So as we move into the outcomes, in the end, we believe about 15 million hectares burned in Canada, which was more than double the previous record of 6.67 million hectares, which was set in 1983. You may have heard some other values for the year for total area burned, and we'll talk shortly about why that might be. For this figure, you're looking at a timeline of total area burned within Canada, and we've divided the country into the east in purple, the west in yellow, and the north in orange. And each year, the color of the stacked bar chart tells you how much area burned in each of those regions. In 2023, more area burned in each of those three regions than in any other year, in addition to the cumulative total exceeding that historical maximum and also the historical average, which is indicated with that dotted line. 4 provinces in Canada set their record for area burned in 2023, and several others had their sort of top 2 or top 3 years as well. And when we look at that historical average, that dotted line, that's 2.1 million hectares, which is what we might typically experience, at least between 1986 and 2022. And the 15 million hectares burned in 2023 are 7 times that historical average. So if we move to our next slide, we'll go to that asterisk beside the total area burned. You may have heard some other values. For example, 18 million hectares was really widely reported. And this is just because there's multiple different data sources for area burned in Canada. During the fire season, active fire statistics are collected by the Canadian Interagency Forest Fire Centre, and that's where most of that 18 million hectare figure came from. We also have another product that we use in Canada called Fire M3 or just M3. And this is mostly produced by our colleague Peter Engelfield. And to do this, we use satellite thermal anomalies or hotspots. And this shows a really similar value to the agency data, so 18.5 again. But when we correct that, because we know that the hotspots overestimate area burned, if we use a correction to historical area burned, we end up with something like 16 million hectares when we look at the M3 values. One thing that's sort of key to highlight here, if we look at this figure in the middle, you're looking at essentially an area burned with those sort of brown or purple colors, and then healthy vegetation is there in green, and you can also see lakes and water bodies, rivers in that sort of black-blue color. So if we look in that area burned in the middle, you can see unburned islands of green healthy vegetation and a lot of lakes and water. And typically those differences account for the higher area burn reported from these other data sources. So when we use these satellite type maps, these are a product that's collected in Canada called the National Burned Area Composite, or NBAC, which is developed by our colleague Rob Skaken. And this is sort of like our best quality available maps that removes those unburned islands and water bodies. So the difference there accounts for that difference in the area burned. And thus far this season, Rob has mapped 12 million hectares with NBAC, and then we consolidated the remaining 3 million from that M3 product. Sorry, Piyush. So if we move on, it was also a record-breaking year for human impacts, with approximately 232,000 people evacuated as a result of fires and close to 300 evacuation orders, which is the highest number in the evacuation database that CFS maintains. The table on the right is showing you the 10 largest evacuations since 1980, and those highlighted in yellow occurred in 2023, with Northwest Territories, BC, Nova Scotia, and Alberta all experiencing really large numbers of evacuees. And we should also note here that these are individual evacuation events at the municipal level, but if you look at a larger region, it's even more people. So moving on to our next slide, it was also a unique year in terms of the fire response. Starting with the map on the left, this is showing agency reported fires by the type of suppression that they received. So the size of the point is telling you how big the fire got, with bigger points indicating bigger fires, and then they're colored by full response, modified response in yellow, and monitored response in green. And then that pink color underneath is showing you the area where generally we expect there to be full suppression in Canada. And what you can take away from this is that although many of the very large fires burned in these areas without full suppression, so they're either monitored responses or modified, there are still many large fires that burned where full suppression was attempted. And clearly 2023 was really challenging for fire management and firefighting. That's also reflected in the national preparedness level, which CIF-IFC orders every year. You can look at the timeline of that on the top right with the bar chart, which is showing you the number of days at national preparedness level 4 or 5. On May 11th in 2023, Canada went to national preparedness level 5, which is the earliest that we've done that, and stayed at that level for 120 days continuously. Overall, Canada was at national preparedness levels 4 and 5 for 133 days. And again, to reiterate, those levels indicate that there's significant resource sharing required across regions. So we need firefighters from different provinces and territories. And in years like this one, especially at preparedness level 5, international people as well. So in 2023, we received international support from 12 different countries, as well as the European Union, which represents many different countries. And this included importing over 5,500 personnel. From here, I'm going to hand it off to Piyush to speak about the smoke and air quality we experienced in this year.
Thanks, Ellen. See right. Yeah, so in terms of air quality, obviously 2023 was a severely smoky year across Canada. What we're showing here is the last 6 years of air quality alerts. So each of those colors represents the number of alerts in each region. And then 2018 up to 2022, you can see that the highest color bar there is 100 plus. And there were very few, if any, I can see regions that had 100 plus air quality alerts. However, in 2023, you can see they even had to add another color bar because there were regions, particularly where a lot of that fire activity was occurring in Western Canada, where we had well over 100. Actually, sorry, these are the number of days of air quality alerts. So we had well over 100 days where the air quality was poor in some of those regions. So just moving on. So in total, when we sum over those air quality alerts, June had over 1,400 alone in 2023. You compare that to some of the previous years, and the next highest year was actually 2021 in July, which was following the Pacific Northwest heat dome, of course, if you recall, led to extensive fire activity throughout Western and Central Canada. So that was one of the next closest events. But even so, 2023 exceeded the number of air quality alerts for multiple months over that single event in 2021. We also have data from the Environment and Climate Change Canada firework model, which is known more formally as the Regional Air Quality Deterministic Prediction System. So this provides 72-hour forecasts of ozone, nitrous oxide, and PM2.5. So if you're familiar with wildfire smoke or air quality metrics, PM2.5 are particles of size 2.5 microns or less, and they have implications for cardiovascular health, because those are the size of particles that can be drawn directly into the lungs. So this model is run at 10-kilometer resolution over North America, and is used to forecast PM2.5 and air quality health alerts for Canada. So just looking at the results there from that model run between, I believe this model is from May to September, and this is the number of days where that PM2.5 level exceeds the threshold of 27 micrograms per meter cubed, which is one of the air quality standards used in Canada. So you can see in terms of aligning that with the air quality alerts, that region in Western Canada, sort of at the intersection of BC, Alberta, and Northwest Territories, you had days, some regions where the air quality exceeded that threshold for 60 or more days. So severely poor air quality for extended periods of time. And of course, the Canadian wildfires really made the international headlines when that smoke drifted into the eastern seaboard in the US. So Alan mentioned earlier that the worst air quality in the world occurred in New York City on June 8th, just for that day, I should say. I'm sure there was worse air quality in other periods during the fire season. And this video on the right-hand side, I'll just play it a couple of times. This shows that a lot of that smoke, which you can see coming down from those fires, sort of, I'm not sure if you can see my hand, the cursor here, but from this region here, a lot of that smoke was pulled down into the eastern seaboard. In fact, this happened because there was a low pressure system sitting over eastern Canada, and basically that cyclonic flow sort of acted as a conveyor belt, pulling all that smoke down into the eastern seaboard. And smoke actually also made its way into Western Europe from those Quebec fires. Another example of extreme fire behavior was the formation of pyrocumulonimbus clouds. So these, also known as pyro-CB. So these are clouds which are basically generated above large fires due to extreme pyroconvection. So what that means is that if you have an intense heat source, such as a fire, that can lead to extreme convection, which basically there's a plume that forces or ejects heat and moisture into the upper atmosphere, and it generates these thunder clouds, which themselves can actually generate a lot of lightning. So 2023 was exceptional in this regard with these events. We had 140 events identified in Canada in 2023 alone, and there was only 164 globally. So most of those events were due to these wildfires in Canada. And you can see that the highest number of these events occurred in July, which is typically the hottest month of the summer. I have a little animation here where we have used some remote sense data. What you're looking at is, I'll just explain what this color bar is on the right. Basically, it's the brightness temperature of the cloud top height. So what happens is that the moisture, which is ejected into the upper atmosphere, at some point condenses and forms this cloud. And this typically happens when you're below about minus 40 degrees Celsius. So it's quite high altitudes. So what you will see here is that as I play the video, you'll see these sudden puffs occur where the pyrocumulonimbus cloud has formed at that dark blue or purple color where the thundercloud has formed. So you can see there, like in Northwest Territories and Alberta and some vents here in the northwest of BC. I'll play that one more time. That suddenly, sort of towards this time is UTC, so this is sort of evening activity for the local time zones there. You see that suddenly those thunderclouds form. I'll just do it one last time, just for good measure. Yeah, so there were multiple events. There was at least 10 events there. I haven't actually counted them, so. So I'm going to go back to Ellen at this point. She's going to talk a little bit about reburns.
Thanks. Yeah, of course, it would not be a forestry lecture without a little bit of ecology, forest ecology. So we'll talk a little bit about some short interval reburns. It's worth stating fires are a natural occurrence in Canada. The forests and tree species that we have evolved with them for many years. So we typically expect forests to recover pretty well across that 15 million hectares burned that we talked about. However, when fires happen in a manner that's outside of the historical fire regime condition, we can actually see pretty serious ecological impacts. And one example of that is short interval reburns or severe fires occurring in very rapid succession. So I'm not talking about sort of low intensity surface fires that might happen quite frequently in parts of like southeastern BC, for example, rather severe short fires. And these inset maps here are showing examples of two different boreal regions, with the 2023 fire perimeters shown in that kind of like salmony color. And then overlaps of any recent fire from the past 20 years are shown in that darker maroon color, indicating a short interval reburn using a 20-year cutoff. So in Canada, in total, we had about 1.2 million hectares reburn in 2023, and that's 10 times the national annual average area reburned, and we can compare that to the 7 times the average for the total area burned. And previously, 1995 was the largest year on record for short interval reburns in Canada, and in 2023, we doubled that record for area reburned, which is essentially on par with that more than doubling of the total area burned record as well. Why do we care about short interval reburns? If we move on to the next slide, generally we expect recently burned areas to resist fire spread. So there's very little fuel there. It's already been removed. It's unlikely to burn. And yet when we have really severe fire weather, we can see these events happen. And when they do, there can often be poor or even absent forest recovery in those reburned areas, which is quite concerning. It's also worth noting that I used a 20-year definition of a reburn here, which is honestly very conservative, ecologically speaking. There's lots of tree species that are still immature and not fully producing cones, upwards of 50 years between fires. So we're really looking at sort of a concerning area that might be understocked or regenerating poorly in the future. And also even further limiting what I was able to show here, I didn't look at commercial forests that had been replanted and are also at a young, immature stand age. If you want to know a little bit more about that, our colleague Jain has done some work with some collaborators looking at Quebec specifically, and they found that over 300,000 hectares of commercial forests could suffer regeneration failures because of being burned in 2023 while stands were immature. I think we're back to Piyush for
Yes, we
why
are.
was it so special?
Yeah. So so we've talked about the impacts the 2023 fire season, you know, from a ecological point of view, from social impacts through the evacuations, so the area burned, when and where events occurred. So what were some of the main drivers of the 2023 fire season? So of course, we need to talk about extreme weather and we need to talk about climate. 2023 was hot and it was dry. So what we're showing in these maps on the left is the surface temperature, the mean surface temperature between May and October. And we're using reanalysis data that goes back to 1940. And we're ranking those mean temperatures in 2023 relative to that time period. So you can see that where they are, that dark red color, 2023 was the hottest for those regions across the fire season. So most of Canada was either very near the hottest year, but many, I would say more than 50% was the hottest it has been in that time record. And sort of following along from that, we can also look at vapor pressure deficit, which is more a measure of atmospheric aridity, so how dry the atmosphere is, which is also very important for fire, of course. And we can see across most of Canada, it was extremely dry and was record-breaking levels of aridity. And of course, that equates to fuel aridity, so how dry the fuels are or the forest is. So it was hot. Okay. Second, snow melt was early in most places. So the map on the left shows the timing of snow melt. So you can see snow melt was very early through much of Alberta, for example. The plot on the right shows the departure. It says day of year, but it should be the number of days earlier or later than what is normal. So you can see, particularly through Alberta, Northwest British Columbia, Northwest Territories, and Quebec, snowmelt was much earlier than normal. So the second thing we need to look at is the drought conditions. So the data on the left is from the North American Drought Monitor. And it's a time series of when the conditions were, well, the percentage of each region, sorry, which were abnormally dry or in drought by the definitions that they use. And this is by province or territory. And the bottom right plot shows, first time series shows the Canada-wide. So the main point I want to make here is that in Western Canada, looking at the dashed line, which is the 2022 conditions, much of Western Canada was already in severe drought coming into the 2023 fire season. And then those drought-like conditions carried over into 2023. Whereas if you look at Nova Scotia and Quebec, which are these middle two panels on the right here, you can see this was not the case. In fact, conditions were either normal or well below drought conditions in 2022 or at the end of 2022. And then in 2023, due to the lack of precipitation and above average temperatures, Nova Scotia went quickly into drought-like conditions, and that mirrored the fire activity that we saw early in the fire season of May. And Quebec also went quickly into drought-like conditions sort of towards May and June. And so when we look at the drought code, which is one of the outputs of the Canadian Fire Weather Index system, which we use for establishing fire danger, we see that in May, we had extreme drought code conditions in Western and Central Canada. And then in June, those conditions also emerged in Quebec. So if we just look a little bit closer at that intensification of drought in Quebec, we can look at, this is data from which is from a land surface model that incorporates satellite data, so incorporates observations. And this is looking at the root zone soil moisture. So this is kind of equivalent to agricultural drought. So the plot on the map on the left shows the maximum amount of 2-week drying that occurred between March and June. So you can see basically the more negative those values, the faster or more intense drying that occurred. So you can see that that occurred across much of Ontario and Quebec. And you can look at the timing of that particular 2-week drying period on the right-hand map, which shows that a lot of that drying occurred around the end of May and early June, which is basically when a lot of those fires started at the beginning of June in Quebec. Another reason why we had such an extreme fire season was lack of rainfall. So this is those rankings again, but this time for precipitation between May and October. So this is precipitation being what it is. This is a lot more variable across the country, but you can see that a lot of those dry spots where we had record-breaking lack of precipitation or precipitation deficits were exactly where a lot of those large fires occurred. So if you look at the map on the right, you know, across those regions where the largest fires in Alberta, Northwest Territories, British Columbia, and Quebec corresponded where there was a large deficits in the rainfall. And that sort of ties into, Alan will talk about it in a couple of minutes, but sort of why some of those fires or enabled fires to burn for a very long time for months at an end, and that's how we ended up with our 15 million hectares. And she'll dive into that a little bit closer. I just want to talk a little bit about extreme fire weather conditions. So as I mentioned, we use the Canadian Fire Weather Index system in Canada, and it's used throughout the world also. If we look at the proportion of the area of the forested area of Canada that experienced extreme fire weather during 2023. So that red curve shows the normal conditions from 1991 to 2020. So it sort of follows the usual seasonal variation. But when we look at the black curve, which is 2023, we can see that it exceeded normal conditions by quite a lot. In fact, over a third of Canada's forested area was in extreme fire weather conditions in May. And in fact, it was very much that early and sustained extreme fire weather conditions that enabled so much of that fire activity in Canada. And when we look at the correspondence between the daily area burned, which is that top right time series, with the extreme fire weather conditions, as I defined earlier, which is the bottom left time series. So that is the proportion of each province or territory which is experiencing extreme fire weather conditions at any day of the year. You can see there's a pretty good correlation between the area burned and those extreme fire weather conditions. So I'm highlighting 2 days there. June 22nd was one of the biggest days of the year, over 400,000 hectares burned, mostly due to fires in Quebec. And then a second day, very late in the season, which was surprising to many, was September 22nd. And interestingly there, a lot of the area burned was Northwest Territories, Alberta, and British Columbia. It was extreme fire weather conditions, but not as extreme as earlier in the season. And the reasons for that is really around large fire growth. And the fact also that a lot of that fire growth was driven by strong winds, but are not necessarily captured by some of the metrics that we use. And of course, we should talk about ignitions. The full analysis around ignitions has not been done yet, but historically, we know that 75% of fires are lightning caused, and this results in 91% of the area burned. In 2023, there was actually less lightning and less lightning caused fires than normal. But those fires, that percentage of lightning caused fires resulted in 93% of the area burned. And when, you know, one can speculate on the factors that why that might be the case, that more area burned due to the lightning caused fires, even though there's less lightning. It could be just the distribution of where those fires occurred, you know, not being in areas with full suppression, for example. But a full analysis is yet to be done. So I think we're switching back to Ellen at this point.
Yeah, that's right. Yeah, so as a result of all those conditions Piyush just described, we had really exceptional occurrence of very large fires in 2023, and this played a big role in the final total area burned. So if we look at that map of Canada that you've seen a few times already, we've got all the fires that happened, and when we narrow that down to just the 20 largest fires in 2023, those 20 fires account for half of the area burned, or 50%. When we narrow it down further to just the 5 largest fires, these account for a quarter, or 25% of the area burned. The largest fire of those 5 shown here is that one that's over 1 million hectares at the intersection of British Columbia, the Northwest Territories, and Alberta. But it's all kind of worth highlighting that there's one that's so close to being 1 million in northern Quebec as well. And again, to put that into some context, to remind you, in a typical year in Canada, we have about 2 million hectares burned. So that one fire at the intersection of the provinces and territories in the west would be equivalent to about half of that, and that other one in Quebec almost compensates for the other half. If we look more closely at that specific border fire that's very large, Piyush can start an animation here, but we're going to talk a little bit about the progression over time. We might play through this a few times. So as that fire grew, it started in May, and we've got sort of 2 separate ignitions, and then there's a bit of a calm period in June, but the fire doesn't necessarily go out due to the lack of that precipitation or fire-ending rain that Piyush was talking about. And again, there's a bit of a calmer period as we get into August, but then these wind events pick up, and we just really see it take off again and continuing to burn all the way into September. Let's maybe play it through one more time, just because I think it's a very cool animation and very interesting. But again, we've got fires starting near each other in June that, although they don't necessarily continue to grow consistently the entire time, there's a few pauses here and there, but we never really manage to extinguish that fire, meaning that there's always already an existing active fire on the landscape. That means when we get those big spread events later in the season, it's still contributing to this massive area burned. We call this a complex because it's multiple separate fires that eventually burned together. Sometimes people use complex to just mean many fires burning near each other, or sometimes it can mean fires that merged. But there was quite a bit of this happening in Canada, and that's really part of how we ended up with these really massive contiguous areas burned. So if we delve in a little bit further to why it matters that there were so many large fires, as Piyush mentioned, there was not as much lightning fire as normal in Canada in 2023, and there were also fewer ignitions overall relative to historical conditions. So we had 6,657 fires in Canada in 2023, and that's compared to 8,000 fires in an average year. So that's quite different. But the role of those large fires is kind of explaining the sort of opposite effect in the area burned. So if we look at the plot on the left, in 2023, there were 60 very large fires, so fires over 50,000 hectares in size. And those 60 fires were responsible for 73% of the area burned. And that's compared with an average of about 7 fires of that size in a year, which would then generally contribute only 41% of the area burned in the historical record. So if you look at that proportion plot that's right beside it, you can see that smaller fires, so fires less than 50,000 hectares, are usually responsible for just about half of area burned in Canada, whereas these really big fires made up for that in style in 2023. We have also talked about like the early season conditions that contributed to this, and part of why these fires got so big is because they began very early. Many fires that started in May and June continued to burn through the entire season, like that animation that we just showed on the previous slide. And these contributed the most to the area burned. So if you look at the plot on the right, it's showing you the cumulative area burned for fires that started in each of these months. So you could see that May and June fires really contributed a lot of area burned and just didn't get extinguished. And in fact, over 2/3 of the area burned in 2023 was from fires that started in the early season in those 2 months. I think we're back to Piyush to wrap it up with some conversation about climate change.
Yeah, thanks, Ellen. I think, it's hard to talk about 2023 fire season without talking about climate change. And I think it really sort of entered, there was a lot more discussion of it in the media and a lot more, I guess, conversation around what role did climate change exactly play. So I'm not going to answer that question entirely here, but I'm just going to touch on it. A lot of the analysis is yet to be done, I think. But some of the things we can say is 2023 was hot. It was a very hot year. So globally, in fact, it was the hottest year on record. And there are multiple sources. This is just one from the European Centre of Medium Range Weather Forecasting. So their estimates were that it was 0.6 degrees warmer than the 1991 to 2020 average, 1.48 degrees warmer than the 1850 to 1900 pre-industrial level. So that's getting very close to that 1.5 degree threshold that we talk a lot about, that we want to restrict the climate, global warming to, I guess, minimize some of the larger impacts. But during the 2023 fire season, Canada was even hotter than that. We were 2.2 degrees warmer than the 1991 to 2020 average over the fire season. And those temperature rankings I already showed, it was record-breaking temperatures, mean fire season temperatures across much of the country. So some of the other things we know is that extreme fire weather conditions are increasing. This is sort of an extended analysis from a paper that we did a few years ago looking at trends in extreme fire weather. So the three metrics there are the fire weather index, the 95th percentile, the 95th percentile of the initial spread index, which is another measure of how extreme fire spread can be. And then we have the vapor pressure deficit, 95th percentile on the bottom there. And the colors of each bar correspond to the global land surface temperature. So this is anomalies in each of those metrics globally over the time series. So you can see that really in the last 20, 30 years, we're sort of getting a very strong upward trend in those anomalies. So fire weather extremes in fire weather are sort of occurring as the global mean temperature increases as well. And in fact, for two of those metrics, FWI 95th percentile and vapor pressure deficit 95th percentile, you can see that was the most extreme year. 2023 was the most extreme year on that record. In fact, 9 of the warmest years on record have occurred since 2015. So another aspect of this we can look at is if we just look at Canada specifically in the forested area of Canada, we can use slightly different metrics. Here we're looking at the percentage of that forested area shown in the map, which exceeds the 95th percentile. And we can see by looking at the fire weather index or the vapor pressure deficit that 2023 was a record-breaking year in terms of extreme fire weather conditions relative to that 1940 to 2023 period. So in terms of, I think it's clear that 2023 was a very extreme year. Now the question is, how much of that to what degree was 2023 an outlier, or was it climate change, or was it some combination of natural variability and climate change, which I think will ultimately be the answer. The specific question has not been answered yet, but there's analysis being done. What I can point to is some of these new studies around climate attribution. So these studies are able to use these new techniques where basically they can run 2 models of the climate, one with the sort of the observed forcing, so the amount of CO2 that we currently observe in the atmosphere, and then one where you kind of roll back the clock back to 1850 to pre-industrial times, and you use the carbon forcing or the amount of carbon that was in the atmosphere then. So that's typically referred to as just natural forcings. So before the industrial age, increase the number of the amount of CO2 in the atmosphere. And then you compare those two, the sorts of climate that you expect from those two different models, and you're able to make some conclusions about what the effect of increased CO2 has had on the climate. So, and in fact, you can even take that a step further, and if you have a good relationship between various weather or climate variables and area burned, for example, you're able to attribute the area burned to anthropogenic climate change. So there's a study here on the left that came out earlier last year based on California, fire in California, and they concluded that all of the increase in area burned in California since 1971 can be directly attributed to anthropogenic climate change. And then also last year, a study came out by some of our colleagues based on the World Weather Attribution Framework, and they looked at the fire weather conditions, and they concluded that seasons of the same fire weather severity as 2023 were 7 times more likely under climate change, and with the same fire weather extremes. So this is a slightly different question. This is any period which had of 7 days or longer, which had extreme fire weather conditions. Those were twice as likely. The extremes that we saw in 2023 were twice as likely under climate change than without. So I'm going to end it there and say thank you. And thank you, Alan, for co-presenting with me. If anyone has any questions, they can contact us at those email addresses below. And hopefully we've left enough time for some questions.
Thank you, Piyush and Alan. That was a great presentation. Now let's move on to the questions. While we're waiting for participants to finish typing their questions, let's take a moment to fill out the post-webinar survey. So I'm going to launch it now. One moment. So there are 2 questions included in this survey. You may need to scroll down to see the second question. Hey, so the first question for Alan and Piyush, is there going to be any action to adapt to the likeliness of another bad fire season coming up?
I can maybe give it a shot, and Piyush, feel
Sure.
free to chime in. I know the piracy question will go to you anyway. So I think, yes, definitely. It was a super concerning and super difficult year for all the reasons we just emphasized. You've already heard, for example, in the news that Alberta has shifted their fire season start this year because they're anticipating another bad year, and changes like that leading to earlier man up at agencies indicate that like we're already trying to respond to this. It's an interesting interjurisdictional problem in Canada in that fire is individually managed by provinces, territories, and Parks Canada, and then the federal government does some scientific and support work, but we don't generally manage fire necessarily, but there's been a lot of effort to provide funding for provinces and territories to alter their plans and capacity. So a lot of those actions and decisions will be made at the agency level, so within individual agencies, how they're going to respond to that. But I'm also aware that there's been sort of within agency after action reviews, as well as a couple national style after action reviews, I think coordinated through the Canadian Interagency Forest Fire Center. So I'm optimistic that we'll be making changes, and I think essentially we're forced to, right? Like it's going to be a massive problem going forward. So we will be responding to it, and hopefully in a dynamic and proactive way, I guess I would say.
Thank you, Alan. Next question for you is, how was the PICO CB quantification made at the global scale? What is the data source?
So that data was shared with us from my colleagues in the US, including David Peterson. They are currently preparing a publication, which will outline their algorithm and so forth, but that is not available quite yet. So, I'm basically saying I can't answer that question because I'm not aware of exactly the details of how they established those PyroCB events, but I know that they have developed an algorithm and applied it globally, and that research will be forthcoming.
Thank you, Piyush. Next question for you is, any thoughts on why Manitoba had a less severe fire season?
I can have a go at that. So, and you may also ask about Ontario, which had very extreme fire weather. So I'm just going to guess it's ignitions. It's fire, as everyone on this call I'm sure can appreciate, is a complex phenomenon. You need several things to kind of happen at the same time. So you need, the fuels to be receptive. You need fire weather conditions for those fires to grow to a size where they're not easy to contain if large fires are to occur. Not that we want large fires to occur. But you need ignitions as well. So those things have to kind of occur concurrently. And maybe they had extreme fire weather conditions, but had very few ignitions, or maybe the nature of the lightning storms that were there brought more precipitation than it brought in other areas where, so-called dry lightning, which allowed fires to take off, whereas there was more precipitation associated with those lightning starts. So I don't know if Alan, you have anything to add?
Yeah, maybe just briefly, I totally support what you said, but I'm looking at your slides on another screen, and Manitoba and Ontario, their timing of snowmelt was a little more typical or even later compared to what's normal for them. And then concurrently, the period that they had the most extreme fire weather, if we think back to those slides that Piyush showed that had timelines of the 95th percentile of fire weather, and then also timelines of area burned, Ontario and Manitoba experienced some pretty severe fire weather in like June, but they had a more typical snow melt. And then when we actually look at like when they had the biggest area burned, it was more so June, July. So I think there was a mismatch kind of in the timing of the more extreme fire weather that they experienced relative to ignitions, exactly like Piyush said.
Thank you, Piyush and Alan. Next question is, Canadian Forest Service did an extensive national fire prediction report a few years ago. Will the 2023 season be compared to the forecast in this report?
I'm wondering if this is referring to the blueprint, which I didn't think had predictions. Piyush, do you know what that would be?
Yeah, sorry, I'm not sure. Maybe I'm not sure who asked that question, but maybe they could point us to that report and I can get back to them directly. Let them know.
Yeah.
I'm not familiar with any planned after action reports here.
It's also possible that CFS colleagues in the audience might know what report that is and might be able to weigh in. Sorry, we are not able to answer it that well.
No worries. Let's move on to the next question. Regarding the climate attribution slides, to what extent have the legacy impacts of fire suppression and management been considered in the California or Canada studies?
That's a good question. I did read that California study, but I have to be honest, it was quite a while ago. I can go back to that slide if someone wants to take note of that. Whoever asked that question wants to take note of that, of the reference there.
I can take a guess kind of in answering that. The impression I have, particularly for the Quebec one, but also for the California one, I'm guessing they did not examine it directly. From reading that statement about nearly all increases in the California one, they're kind of implying that weather is the more important driver there. And maybe just for context, backing up a little bit for anyone in the audience who's like, what are we talking about? There's certainly observed in certain ecosystems in Canada and in other places where we used to have more frequent fire, the introduction of fire suppression, colonization, cessation of cultural burning, or at least vast reduction of it in some cases, has led more fuel, more vegetation, more trees to grow and fill in areas to increase that fuel load, which does increase fire risk. I don't think it was examined directly in either of those studies. The implication in the California one is that they conclude that climate is more important than that effect. I know that going forward, that particular question of kind of not like, wouldn't want to like pit them against each other in terms of the importance of one another, but the relative strength of those effects on the changes we're seeing is an active area of study for a lot of people in Canada and internationally. But I would suggest that fuel accumulation paradigm is much more so like it's pervasive, but it's much more so a problem in certain ecosystems. And so there are parts of Canada where we don't necessarily think that that's a huge contributor relative to climate.
Thank you, Ellen. Moving on to the next question. Was the effect of recent wildfires on the containment of 2023 wildfires relevant? If yes, up to which field age is the effect visible?
I can take a stab at that, Piyush.
Another question.
I'd love to see someone do a study examining exactly that question, specific to 2023, because as I said in some of those earlier slides, it was an exceptional year in terms of fuel ages not providing the boost to containment that we would expect. From other research that we've done sort of about short interval reburning and how long recently burned areas can act as a fire break in Canada, we find the strongest effect of a recently burned area in terms of increasing the resistance to spread for about 10 to 15 years. And then beyond that, at least in boreal forests specifically, which I'm more familiar with, we kind of start to see that somewhere around 20 to 30 years, the effect starts to decline. Kind of makes sense if you think about it, like for trees to be growing sometime around there. It's not the same forest that it was before fire necessarily, but it still has now quite a bit of fuel and mature looking trees. However, that resistance effect continues for beyond that. It just sort of becomes reduced in strength. So in terms of specifically 2023, I can't answer that. But when we look at our national data, we kind of find that the strongest effect is between 10 and 15 years. However, it does continue for up to 30 and even longer in some regions, particularly further north. I think people have found like up to 50 years, there should be some resistance. So it's an indicator that that extreme fire weather really overwhelmed that control in a way that would have been super challenging for fire management.
Thank you, Ellen. Next question in the chat pod. Are human-caused ignitions rare enough that they don't have a huge impact on area burned?
I can take that. Sort of the largest fires we get from human-caused ignitions tend to happen in the boreal plains, which includes Alberta. And those are spring fires pre-green up. So in 2023, 7% of the area burned was from human-caused ignitions. I don't know if I made that point. And that's not atypical, I think. That's pretty close to the number in any other given year. But it's highly seasonal. So they tend to occur in May or early season. We tend to get green up a bit later than the rest of the country here, so sort of mid-June, I guess. So, you know, you look at some of those large fires that we've had in Alberta, you know, they are significant, they're large, and they're very impactful because we have a lot of people living on the landscape. They, you know, the Fort McMurray's, so forth, you know, they can end up in a large, I don't know if the final fire cause was assigned for that fire, but I believe the understanding is it was human caused. So yeah, at a local level, very impactful. Overall, in terms of total area burned, still a much lower percentage than lightning caused fires.
Yeah, I just want to add to that in terms of like the rarity of specifically the ignitions. In Canada, human ignitions are about half of ignitions. So it's really the location of those ignitions, like Piyush was talking about. So it's not necessarily that they're rare, although shout out to all of Canada, human ignitions have been declining for a really long time. So we're actually lighting fewer and fewer fires accidentally or intentionally in very rare cases. So that's really positive, but they're super impactful when they do occur, which Piyush already emphasized, but they're not necessarily rare. They just tend to happen in areas where we respond to them very quickly and we successfully suppress them. So they stay smaller.
Thank you, Ellen. If there are no more questions, I would like to bring this session to a close. Thank you all for participating in our CIF electronic lectures. And once again, thank you very much to Ellen and Piyush for this great presentation. Bye, everyone.
Thank you.